All right, let's talk about something that's in pretty much every one of our homes, but we almost never see it or even think about it. Electrical grounding. It is, and I'm not exaggerating, the silent protector that stands between you and a really nasty shock. So we're going to break down exactly how it works. So let's just jump right in with a pretty intense question. How on earth can your trusty washing machine, or your toaster, or your refrigerator, something you use every day, suddenly turn into a deadly hazard? It sounds like something out of a movie, but it's a very real risk, and understanding why is the key to staying safe.
To get to the bottom of that, we've got to look at the hidden danger lurking inside these machines. See, the whole problem starts with a simple internal fault, something you'd never see, that can create a life or death situation in the blink of an eye.
Okay, so picture this. Inside your appliance, there's a live wire. Over time, its plastic insulation gets old and cracks, or maybe it just gets jostled loose. And then it happens. That live wire touches the metal frame of the machine. Instantly, the entire metal shell, the part you touch, is now electrified. It's carrying the full voltage from the wall out.
Now, if you don't have a grounding system, all that dangerous electricity is just sitting there, trapped. It has nowhere to go. So the moment you walk up and touch that appliance to open the door, bam! Your body closes the circuit. You become the one and only path for that current to escape to the ground, and that results in a massive, and potentially fatal, electric shock.
That's a terrifying scenario for sure, but the good news is there's a brilliantly simple solution that acts like a safety valve for electricity. And that, of course, is grounding. So what is grounding, really? Well, at its core, it's just a dedicated physical connection. It's basically a wire that runs from the metal case of your appliance directly to a metal rod that's been driven deep into the earth. You can think of it as an emergency exit for electricity that's gone rogue. The whole system really just has a few main parts. You've got your appliance, you've got a copper wire, that grounding rod buried outside, and it all connects through that 3-pin plug you see everywhere. You know that third round pin on the bottom? That's not for power. It's there for one reason and one reason only: your safety. So how can this simple setup of a wire and a rod actually save your life? Well, it all comes down to a fundamental law of physics. And honestly, this is the big aha moment of the whole system. Here it is, the golden rule. Electricity is, for lack of a better word, lazy. It will always take the easiest possible path to get where it's going. It's just like water flowing downhill. It's going to find the most direct, effortless route to the ground. It's not malicious, it's just physics. And this is where it all clicks. Without grounding, your body, with its relatively high electrical resistance, is the only path available. So the current goes through you. But when you introduce a grounding system, you've given the electricity a brand new option: a copper wire. That wire is a superhighway with almost zero resistance. The electricity has a choice: struggle through your body or zip down the easy copper wire. It's a no-brainer. It takes the wire every single time, bypassing you completely. But of course, for this to actually work, it can't just be any old wire stuck in the dirt. A proper grounding system has to be installed by professionals to guarantee, and I mean guarantee, that it provides that path of least resistance. The pros follow some really specific steps. First, they'll drive a long copper rod deep into the ground until it hits moist soil, because moisture is a great conductor. And then get this, they often pack things like charcoal and salt around the rod. The whole point of this is to lower the electrical resistance of the soil itself, making it even easier for that current to flow away safely. The goal of all that work is to hit a magic number, a resistance of 5 ohms or less. That's not just some random number. It's the industry standard that ensures a fault current can escape to the ground so incredibly fast that it can't harm you. And as an added bonus, that massive, sudden surge of current flowing to the ground will instantly trip your circuit breaker, shutting off the power and letting you know something's wrong. So when you step back and look at the whole picture, what's the big takeaway here? Well, it becomes really obvious that grounding isn't just some optional extra. I think this quote from our source material just says it perfectly. You can have all the fuses and circuit breakers in the world, but grounding is that fundamental physical safety net. It's what protects you from the raw, untamed power of an electrical fault. And what's cool is that it has a double benefit. Its number one job, obviously, is protecting human life, but it also protects all of our sensitive electronic gear. Things like power surges or static buildup can fry the delicate circuits in your computer or TV. Grounding gives all that excess charge a safe path to the earth, protecting your devices too. So at the end of the day, grounding is your silent partner, always on duty, ready to divert danger away from you in a split second. And this all leads to one final, really important question.
how can you be sure the grounding system in your own home is actually up to the job? The only way to really know for sure is to have a qualified electrician test it. It's a simple check that truly could save a life.